Hi, this is Mr. Mack, and this is the concept video on compound and absolute value inequalities. First of all, let's talk about a compound inequality. A compound inequality is basically two inequalities or more that are connected with either the conjunction and or the conjunction or. Let's talk about the conjunction and first. If we wanted to identify the numbers that are greater than 2 and less than 4, those would be the numbers on the number line that would be the overlap of the graph x is greater than 2 and the graph of x is less than 4. Now, if you were to project this down on the number line, what you would end up seeing would be an interval with open ends in this particular case that goes from 2 to 4, because the numbers that are between 2 and 4 are both greater than 2 and less than 4. The conjunction and, when used in this case, is saying that we would expect both of these conditions to be satisfied. So for x to be greater than 2 and x to be less than 4, those would be the numbers between 2 and 4. Now that's a compound inequality. A lot of times we would write that 2 is less than x is less than 4. Now notice what we've got here is an inequality that actually has two inequalities in it. Now it's very important that if you have one of these inequalities, that both of the inequality signs go in the same direction, and it must be the conjunction and that puts these together. You can never combine two inequalities that are linked with the conjunction or in a single statement like this. So if you see a statement like this, you have to know that this is an and. In other words, if you were just confronted with 2 is less than x is less than 4, then you would know that that would be 2 is less than x and, 2 is less than x, x is greater than 2, and x is less than 4. And in fact, many times that would be the way you would solve them. If you had, for example, 5 less than 3x plus 1 less than or equal to 7, then the way you would solve that would be to write the inequality 5 is less than 3x plus 1 and 3x plus 1 is less than or equal to 7, and you would solve each one of these. Now, in the first case, just as we were solving simple inequalities, you would subtract 1 from each side to get 4 is less than 3x. Then you would divide both sides by 3 to get 4/3 is less than x. That would be connected with an and to the solution of the other one. Now, for the other one, you would subtract 1 from each side to get 3x is less than or equal to 6, and then you would divide both sides by 3 to get x is less than or equal to 2. So the solution would be 4/3 is less than x and x is less than or equal to 2. And this combined inequality could be combined to write 4/3 is less than x is less than or equal to 2. Now the graph of that, here's 0, 1, 2, 3. We would have 4/3, which would be right here, and we'd have an open circle on 4/3, and then we'd have a closed circle on 2 because of they're equal to, and we would graph the numbers in between. Now that's how you would handle a combined inequality that has and. The other conjunction that we're dealing with is the conjunction or. Now, with the conjunction or, you would see something like x is less than 3 or x is greater than 5. Now, in a case like this, when the inequalities are linked with the conjunction or, at least one of the conditions has to be true. Ordinarily, only one of them will possibly be true. In this case, for example, there is no number that's both less than 3 and greater than 5 at the same time. So the graph of this or compound inequality, here's 0, here's 3, here's 5. We'd have an open circle on 3 and we'd color everything to the left, because as long as the numbers satisfy the first part of the inequality with the or, we consider the whole thing satisfied. We would also have an open circle on 5 and we would color to the right, because again, as long as the numbers satisfy x is greater than 5, they would be considered part of the solution. Now, x is less than 3 or x is greater than 5 is as far as you can go with this kind of inequality. You cannot put them together into a single inequality. If you do, it is wrong. So please take care not to do that. All right. Now, the third type of inequality that we want to take a look at in this particular section is the absolute value inequality. And the reason for that is that when we're solving an inequality that has absolute value in it, it generates a combined inequality. Now, let's take a look at a simple example. If we have the absolute value inequality, the absolute value of x is less than 3. If we think about this on the number line for a minute, here's the number line, here's 0, here's 3. Now, the absolute value of x, many of you were taught when you were a bit younger, that the absolute value of a number is really a measure of how far it is from 0 on the number line. Well, any number between 0 and 3 is less than 3 units away from 0. But there are other numbers also that are less than 3 units away from 0. Actually, any number between -3 and +3 would be less than 3 units away from 0. So if you notice, the graph of the solution to this simple inequality looks like this. X is less than 3 and x is greater than -3. Now, what we end up doing, if you'll notice here, is the first inequality that we wrote from the absolute value inequality was the inequality that we had there. We just dropped the absolute value. And then we link this with the conjunction and we write the inequality again. We drop the absolute value, but this time we change the direction of the inequality sign and we change the sign of the number that follows it. So we have x is less than 3 and x is greater than -3. Now, if you had something like the absolute value of 2x minus 1 is less than 5, then you would use this principle with what's inside the absolute value. In this case, 2x minus 1 is less than 5. And then you would combine that with an and. 2x minus 1 is greater than -5. And then each of these inequalities have to be solved. Add 1 to both sides. We get 2x is less than 6. Divide both sides by 2. X is less than 3. And here, add 1 to both sides. We get 2x is greater than -4. Divide both sides by 2. We have x is greater than -2. So we have x is less than 3 and x is greater than -2. Now, as a single combined inequality, that would look like this. -2 less than x less than 3. And if you graphed it, you would have an open circle on -2, here's 0, an open circle on 3, and everything colored in between. Now, since we have the absolute value is less than a number is the value between two values, if we were to have the absolute value was greater than a number, it would be the regions outside. See, if we had, in this particular case, absolute value x is greater than 3, that would be the numbers to the right of 3 because they're more than 3 units away from 0. And it would be the numbers to the left of -3 because they are more than 3 units away from 0 as well. Now, the way the zeros would get filled in is if we had an or equal to on either one of those. Now, if you had something, I'm going to erase some stuff down here. If you had the absolute value inequality, 2x minus 1, absolute value, is greater than 5, you would still solve it the same way. You would write 2x minus 1 is greater than 5, and then you would write 2x minus 1 is less than -5. Notice what I did was the first time I wrote the inequality just as it was, dropping the absolute value. The second time I wrote it, I changed the direction of the inequality sign, and then I changed the sign of the constant on the other side. Now, what we need to do is decide which conjunction goes here. Now, if you have the absolute value on the left, and then the inequality sign, and then the constant on the right, then if it's less than, it's going to be an and. If it's greater than, it's going to be an or. Now, the easiest way I know of to remember this is less than is and, that makes the word land, and greater than is or, and if you just add an E here, that's the last name of a former vice president. So if you remember Land and Gore, you'll know which conjunction to put in between these two, but everything else works just the same. See, we have absolute value 2x minus 1 is greater than 5. Since it's greater than, it's an or. And then we solve these inequalities again. We add 1 to both sides here. We get 2x is greater than 6. Divide by 2, x is greater than 3. Or, over here, add 1 to both sides. We get 2x is less than -4. Divide both sides by 2, x is less than -2. So in this particular case, the graph would have an open circle on -2, and we'd shade to the left. And let's put 0 here. 3 would be about here. And then we would have an open circle on 3, and we would shade to the right. Now remember, with an or combined inequality, you cannot put them together into one single statement for the two inequalities. You've got to leave it as an or. And that finishes this concept up. We're done.